Good morning to all. I'm Sumitra, working as an associate professor in AAA department, and I'm handling microprocessor and microcontroller for third year AAA students. And in this video, I'm going to start with the unit 3, which is getting related with the i51 microcontroller. First, let me explain about the topics which are coming under unit 3. And here we have a depth knowledge of about 8051. After studying this one, after having a discussion over this unit, you people will come to know how this 8051 is getting varied from a processor, and what are the different hardware architecture available for this, and what are the different programming concepts getting related with the 8085 and 8051 controller, and different data transfer and manipulation control algorithms, IO instructions, which is required for writing the programming using 8051, and memory organization also. Let me explain about each and everything in detail in this video. First, why we need to go for learning this microcontroller means because nowadays everywhere we that is in our day-to-day life we are using lot of devices. It may be either a personal information products or a home appliances or even an industrial equipment or a toys. In all almost all these applications, we have a microcontroller. So for we will need to know how this microcontroller play a vital role in all these things, because daily we will be using a phone charger, then mobile phones, calculator, and then keyboard, modem, and even in some of the houses we have a door lock and alarm lock, air conditioner, TV remotes, etc. So while we are using such components, we need to know how these functions, how these components are functioning. So let me go for this explanation regarding the microcontroller. So what do you mean by microcontroller is? It is nothing but a small computer in which we have an on-chip RAM, ROM, and I/O ports. So all these things are available as a single chip. That is the microcontroller. Okay, so for example, Motorola 6811, Intel 8051, Zilog Z8, and PIC 16 Cross. So all these are examples of a microcontroller. So a single representation is given for a microcontroller. In a single chip, we have a processor, RAM, ROM, timer, IO port, and also some serial port for communication devices. All these are inbuilt in a single chip. So, in what way this controller is getting differ from a microprocessor is, your microprocessor is a general purpose, is meant for general purpose, whereas the CPU is there, and we have to provide a separate chip which is having a ROM, IO, everything, right? So CPU is a general purpose microprocessor. CPU of the general purpose microprocessor are getting connected with an external RAM, ROM, IO port, timer, and serial communication port with the help of the data bus and address bus. So the main difference between a microprocessor and a microcontroller is that everything is available on a single chip in case of controller, whereas in case of a processor, all the things are getting externally connected through the data bus and address bus. So these are the differences. So regarding your microprocessor, the CPU standalone and the RAM, ROM, IO, timer are provided as a separate unit, whereas in case of a microcontroller, all components like CPU, RAM, ROM, IO ports, timers, everything is available on a single chip. And here in microprocessor, the designer can decide the capacity of ROM, RAM, and IO ports, whereas in case of controller, since this is already available on a single chip, we can't able to decide the amount or the capacity of a non-chip ROM, RAM, and IO ports. And the microprocessor is having a facility to expand in future cases, but for microcontroller, this is not possible. Not possible means only at the investment of cost for certain applications in which the cost, power, and space are critical. For that alone, we need to go for this one, and it is a general purpose one. And this is meant for single purpose, because if we have a microcontroller for performing a specific function, that is possible only with that controller, and that a controller is not suitable for any other applications. Then coming to the classifications of microcontrollers, here we have classification based on different criteria. First criteria, if you're going to consider the number of bits on which it is operating, we have an 8-bit microcontroller, 16-bit and 32-bit microcontroller. Depending upon the memory or the devices used for constructing that, it is getting divided into embedded and external memory microcontroller, and based on the instruction sets it is having to function, RISC and CISC. And then based on the architecture, it is performing Harvard and Princeton. And again, based on the number of bits, it is getting divided as 8, 16, 32. Based on the chip is also, it is getting IC chip or VLSI code. So here we have the family of microcontrollers like 8050 and Motorola, Quick, Hitachi, Texas, ARM, and others. And this 8051 itself is having a various classification like Intel, Philips, Tonal, Siemens, Dalias, etc. And next, coming to the important features of 8051, it is having a 4K byte ROM and 128 bytes RAM, and it is having an inbuilt four 8-bit IO ports along with two 16-bit timers, and it is also having an 64 external code memory space and 64 kilo data memory space. And it is also having a interface communication required for performing the serial communication. Then coming to the architecture of 8051, it is having the various blocks like on-chip ROM, on-chip RAM, and then the timer unit, and along with the serial port and four IO ports, bus control, and then timing and oscillator circuit, and then CPU, and then interrupt control. These are all the various blocks present in the architecture of 8051. Let me explain about each and everything in detail now. So first coming to the CPU, and we all know that CPU is the one which is a brain of any system, that is central processing unit, and it will manage all the processor, or it will scrutinize all the process that are carried out in the microcontroller, and it interprets the programs that are being printed in the ROM as well as that with it's required to extend them to the projected duty. And its main function is to manage the different types of registers present in the 8051 controller. And regarding the memory, it is organized as from, and that is program memory or the code memory and the data memory. And wherever we have a storage for the program memory, then it is known as read-only memory or ROM. And these programs need a separate storage space. And then it also have a memory to a mask data or the operands for the short term, and this is specified as the data memory, and it contains the 8051 contains the code memory or the program memory, which is of 4 kilobytes, and it is also having a 4 kilobyte ROM, and it also comprises a data memory of 128 bytes. And then coming to the bus are nothing but a group of wires which is meant for transferring the data, that is communication of data to and fro. So this comprises of 8 or 16 or more cables depending upon the requirement. We can segregate the microcontrollers are an 8-bit controller or 16-bit or 32-bit. And here the buses is of different types like address bus, data bus, and the control bus and all. So address bus is meant for carrying the address, that is 16-bit address, and it is used to transmit the address from the CPU to the memory. And the data bus is of 8-bit wide, and it is used to carry the data to and fro. And then the oscillator unit. So oscillator is a digital circuit, and it needs the timer for its proper functioning, and it facilitates the harmonized employment of all buses of 8050 and microcontroller. And then it is also consisting of an on-chip oscillator, which is required for generating a timing signal so that the equipments are working synchronization. And then this oscillator is having an input and output port, so which is meant for inserting the microcontroller in any other gadgets. And we need some IO interfacing ports for a microcontroller port. And this consists of four input and output ports to attach all to the other peripherals. In this oscillator and timer counters, there are two separate counters, and these are used for providing or measuring the intervals to find out the required pulse width of the required operation. And there is an interrupt causing device, and the interrupt is nothing but a subroutine that will require the microcontrollers to execute its requirement. It is helping us to perform some other program whenever the processor is carrying on its own duty. And Inter provide us a method to postpone or delay the current process. Then coming to the pin detail of 8051, and it is a 40 pin IC. And as I mentioned earlier, it is having three different ports and timers and all. So now let me explain about the pins which are related with the functions. So pin one, we can have a segregation like with the pin numbers to pin 1 to 8, 9 and all. Let me explain about pin 1 to 8 is recognized as port 1. So in this diagram, we have pin 1 to 8, which is meant for port 1, which is recognized as port 1, different from the other ports. This this port doesn't provide for any other function. It is mainly meant for acting as a quasi bidirectional input output port. And then pin 9, it is used as a reset pin, and reset pin is used to set the elevator for two machine rotations, right? It is to required for functioning or the early beginning of any other application. And then pin 10 to 17, it is recognized as port 3, and this is a domestic pull-up port with quasi bidirectional port within. And pin 18 to 19, these are employed for interfacing an external clock register to the system clock. And pin 20 is represented as VSS. And then pin 21 to 28 is recognized as port 2, then other than serving as an input and input output port. And this is also having a capacity to multiplex with the quasi bidirectional port. Pin 21.9 is for PSEN, that is program store enable, to interpret the sign from outer program memory. Pin 30 is an external access or EA input used to permit a proprietary outer memory interfacing. Then pin 31 is address latch enable, which is to demultiplex the address data indication of the port 0. Then pin 32 to 39 is recognized as port 0. And apart from acting as an input and output port, it is also carrying a pull-up resistors. And this is a bidirectional input output port. Pin 40 is termed as VCC, which is meant for providing the power supply. So that's all the details regarding the pins of an 8051 and the functioning of each and every block. In the next video, I'll be explaining you how the timers are programmed in the different modes of operation. Thank you all.